Okay, so hopefully by now you've been able to practice and master going from grams of substance A to moles of substance B. Now we're going to take it just a step further. We're going to do a full mass to mass stoichiometric conversion. When the mass of one substance in the reaction is known, we can figure out the mass of the second substance. This is what chemists often do inside of a lab. If we know if we have the balanced chemical equation, we are able to do this large conversion just like this. And so I want to give you a minute, write this down. This is the generic equation or bridge notation for going from the mass of substance A to the mass of substance B. Notice that I have written in the number 1 here and here. Here's why. You notice these little red lines? That's because these numbers are all dependent on our chemical equation. They will give you this number. They will give you the mass of substance A. You, by using your periodic table, will find the molar mass of that compound. And you know by now that 1 mole of a compound is equal to the molar mass of that compound. That's the conversion factor. And what we learned yesterday is that there's this mole to mole ratio that we get from the balanced chemical equation. We know that this is our coefficient bridge. And so what I'm able to do is these numbers come from our balanced chemical equation. Whatever coefficient is in front of substance A that we're starting off with, and then whatever coefficient is in front of substance B where we're trying to go to. And so now that we're in mole of substance B, we know that 1 mole of that substance is going to be equal to the molar mass of that substance. So using your periodic table, you would figure out this number. So let's practice. So here's our problem. We'll go back to what we've been doing. P2O5 plus 3 waters gives us 2 phosphoric acids. All right. And they want to know what mass of water will react with 3,550 grams of the P2O5. So they gave us the mass of P2O5. They want to know the mass of water. So here we go. Start with what you're given. 3,550 grams of diphosphorus pentoxide. Now, first step is we need to go from grams of substance A into moles of substance A. So we know by now that the old unit goes in the denominator, or what we're going from goes on the bottom, 2 goes on top. So we're going from grams of P2O5. Using my periodic table, I figure out the molar mass. I take 2 times the mass of phosphorus plus 5 times the mass of oxygen to get a gram total of 141.9. And I know that the molar mass of the compound is equal to 1 mole of that compound. There's my first conversion. So now I'm in mole of P2O5. That's not what we want. So I need to go old unit on the bottom, mole of P2O5 to mole of H2O. That's my new substance. Notice, please, this is why I tell you to show your work, why you can't do it in your head. Notice that these are 2 different substances, okay? That's why I tell you to label it. Where I started, what they gave us is on the bottom. Where I'm going to, what they want is on the top. These numbers that go right here in front of these moles comes from the coefficients in my balanced chemical equation. So the number in front of P2O5, there's nothing there, so I assume 1. In front of water, there's a 3, so I put a 3. So now I'm in mole of water. This is where we stopped yesterday. We're going to take it 1 step further. They want mass. So old unit goes on the bottom, because remember, the reason why we do this is because we want to be able to cross out these units. So mole of water. We know that 1 mole of water is equal to the molar mass of water. And so I look at my periodic table, 2 times the mass of hydrogen plus the mass of oxygen, and I get 18.016 grams. And there you go. You are set up. So how do I do this? You take 3,550 times 3 times 18.016, hit equals, and you're going to divide that by, well, only divide it by 141.9. There's your answer. You should end up with 1,550 grams of water. That's not too bad, right? All we're doing are taking these conversion factors that we already know, and we are just going to add them all together into one big problem. Let's do another one. All right, here's my balanced chemical equation. I'm going to have 2 formula units of salt. And that's going to yield, and don't forget that delta over the arrow means that I've applied heat. It's going to give me 2 sodium plus Cl2. This is already balanced for you, but always never assume, double check. And so they want to know how many grams of sodium chloride decompose to yield 27 grams of chlorine gas. So what they're saying is, how many grams of this sodium chloride decompose to give us 27 grams of that chlorine? So start with what you're given. Here we go. 27 grams of chlorine gas. First thing we need to do is we need to go from grams of chlorine into moles of chlorine. So old unit goes on the bottom, grams of Cl2. We know that the molar mass of Cl2 will be equal to 1 mole of Cl2. So I look at my periodic table and I take 2 times the mass of chlorine and I end up with 70.90. So now I'm in moles of chlorine, but that's not what they want. So in order to get to sodium chloride, I need to go from moles of chlorine to moles of NaCl. And I'm able to do this because of my mole to mole ratio. This is my coefficient bridge. This is what's giving me the ability to go from compound A into compound B. And these numbers come from my balanced chemical equation. So what coefficient do I have in front of Cl2? Well, I don't have one, so I put a 1. In front of NaCl, I have a 2. So now I'm in moles of sodium chloride, but again, that's not what they want. They asked for grams. So I gotta take one more step. Old unit goes on the bottom, moles of NaCl. And I know that 1 mole of sodium chloride is equal to the molar mass of sodium chloride. So I look at my periodic table. I add up the mass of sodium plus the mass of chlorine. I get 58.44. And now I'm set up. So I take 27 times 2 times 58.44. Multiply all that together. I get equals. And then I divide that by 70.90. And I get an answer. My answer is 45 grams of sodium chloride. So it's not too bad. Rewatch that again if you need to see it. Pause it, rewind, do whatever you need to. Look in your book for some more written down examples. And now it's time to start practicing.